We're surrounded by AI that seems to just get us. It can write a poem, it can answer some ridiculously complex questions, but have you ever really stopped to think about how it's even possible? I mean, how does a machine, a thing that only understands ones and zeros, grasp something as rich and, let's be honest, as messy as human language? Well, the answer is kind of mind-blowing, and it all starts with one single, really powerful idea.
Just think about any simple sentence. It's packed with nuance, with context, with this whole web of meaning we've built up over thousands of years. But to a computer, it sees nothing, just code. So what's the trick? How in the world does it bridge that massive gap from just raw numbers to actual understanding? Well, here's the secret. The machine doesn't try to feel language like you and I do. No way. It does something much, much cleverer. It turns all of language into a map, a giant, sprawling, multi-dimensional map of meaning. And for the next few minutes, that's what we're going to do. We're going to explore this map together. Okay, so if you're going to build a map of every word ever, where do you even start? Well, the first step is actually pretty straightforward. You give every single word its own unique address. Think of it less like a dictionary and more like a massive cosmic atlas. We're giving every word its own set of coordinates.
Yeah, literally every word you can imagine, apple, justice, love, algorithm, gets its own little dot, its own point in this enormous conceptual space. Now, the fancy term for this address is a word embedding, or a vector, but all you really need to know is that it's a unique spot for that word in this galaxy of meaning.
Of course, a map is useless without rules, right? And the main rule for this map is so simple, it's brilliant. If 2 points are close together, they mean similar things. So words like king and queen are neighbors. But words like king and, say, banana, they live on opposite sides of the universe. And that one simple idea, that's the foundation for literally everything else. So what happens when you take that one simple rule, that closeness equals similar meaning, and you apply it to billions and billions of words? Well, something amazing starts to happen. The words don't just float around randomly. Nope. They start to clump together, forming little neighborhoods or even whole continents on our map. So for instance, you'll find this whole finance district over in one area with words like market, stock, and price all hanging out together. And then way over on the other side of the map, you'll find a fruit stand with apple, banana, and mango. They just naturally sort themselves out based on how we actually use them in the real world. And this is the really wild part. Nobody told the AI to do this. No human programmer wrote a rule that said, hey, put all the fruits in one corner. The machine just figured it out all on its own by reading, well, basically the entire internet. These meaningful groups just emerge from the data. It's kind of a beautiful mathematical discovery. Okay, so knowing where words live on the map is one thing. But the real magic, the part that's truly mind-bending, isn't just the locations. It's the roads, the pathways between them. It's the directions you can travel to get from one idea to a totally different one. This is where things get really cool. I mean, it's one thing to know where words are, but what about the relationships between them? How can a map possibly represent an idea like gender, or the connection between a capital city and its country? How do you draw that? To get this, let's try a little thought experiment. Picture yourself standing on the dot for the word king. Got it? Okay, now we're going to take a walk. First, we travel in a very specific direction, the direction of minus man. Then, from that spot, we walk in the direction of plus woman. Any guesses where we end up? You land right on the dot for queen. And I mean exactly on the dot. This isn't a guess, it's math. The AI learned that the conceptual journey from king to queen is the exact same as the one from man to woman. It's a literal physical direction on the map. Just stop and think about that for a second. Really abstract ideas like gender or verb tenses or the relationship between a country and its capital, they aren't just fuzzy concepts anymore. For the AI, they are actual, measurable directions in this space. It turns out language has a shape. It's geometry. All right, so this map is incredible, but how does an AI actually use it day to day, like when you ask your chatbot a question? Let's connect this whole idea to the tech we're all using right now. First thing you have to know is that it's not just single words that get a location. Oh no. Entire sentences, whole paragraphs, even full documents get plotted as a single point on this same map, representing the overall gist of what they're trying to say.
So let's say you have two sentences like the market is bullish and stocks are rising. They use totally different words, but they mean pretty much the same thing. And sure enough, on our map, you'd find their two dots sitting right next to each other, like friendly neighbors.
So here's how it all comes together. When you type a question into an AI, the very first thing it does is find your sentence's location on the map. It puts down a little "You are here" sticker. And then its job is super simple. It just looks around for the closest neighbors, the closest words, the closest sentences, the closest documents, because those are the ones that are most related in meaning. And that's how it finds you a great answer.
So, as we're wrapping up this little tour, what's the one big idea you should walk away with? It's a pretty fundamental shift in how we think about language itself. This whole map that we've been exploring, built from those word embeddings, has a technical name. It's called an embedding visualization. But, forget the jargon. A much better way to think about it is just this. It's the art and science of seeing language as geometry. It's the profound idea that the relationships between our words actually have a structure, a shape that a machine can navigate. And that leaves us with a pretty wild final question. We've created a map for the entire universe of human language. So, what's next? Could we one day create maps for emotions, for logical arguments, or even for different styles of music? If language has this hidden geometric structure, what other parts of the human experience are just out there waiting to be charted?